So in this new unit, we're going to get into ultimately solving inequalities. And what we're going to discover is that when we solve inequalities, a lot of what we've learned, almost everything that we've learned from solving equations is going to apply directly to solving inequalities. But before we can get into the solving part, we want to make sure we understand what an inequality is. And we also want to make sure that we know that beyond just a solution to an inequality, there is also the need to graph our solutions. So the other important thing to know is that whereas with an equation, we have typically one and only one solution. So for an example, something like x equals 5 would be a solution to an equation because whatever that equation is, 5 and only 5 will make the equation true. With inequalities, there's this notion of there being infinite solutions, but with some specific boundaries. Okay, so that's why you'll see solutions like you see down in some of the examples down below. And likewise, when it comes to a solution, we don't just want to see what the solution is, but we want to see some graphical representation of that solution. And the way that we do that is on a number line. Okay, so a couple of important things for us to know before we get started. When we graph, we need to know how to represent uh, any of the four inequality symbols appropriately when we begin to construct our number line. So the two inequality symbols you're probably most familiar with are these. This says greater, and keep in mind that when we read a statement with an equality symbol, it would be read from left to right. So this would be represented as something is greater than, versus here, something is less than, okay? When we get to graphing, there's going to be a dot we're going to have to mark on our number line, and that's going to be an open dot, okay? Likewise, the other two, and maybe less familiar inequality symbols to you, are these. This one is less than, and with the bar underneath it means or equal to, so less than or equal to. And this one is read as greater than or equal to. And we need to differentiate those inequalities that have or equal to in them from the inequalities that don't have equal to. And the way we do that is for greater than or equal to or less than or equal to, we will mark a closed dot on our number line. Okay. Other than that, it's really just a matter of setting up our number line, plotting the value, and pointing the graph in the right direction based on recognizing the type of dot that we're going to use. So right away, we can see in our first example that we are going to have a closed dot because this says x is less than or equal to 7. So the way I'm going to ask you to write your graphs is on your number line, always mark 0. Always mark what I'm going to consider the boundary of your solution, in this case the 7, in respect to 0, just being a positive number somewhere to the right. Notice I'm not asking you to mark all of those additional tick marks counting your way up to 7. All I care about is that you mark 0 as a point of reference. You mark the value that is in your inequality as a boundary, 7 to the right being positive. And now you mark the appropriate type of dot. Because it's less than or equal to, you will mark a closed dot. And because it's less than or equal to 7, that means any value on this number line that's going to be true from the infinitely many values has to be to the left of. Those are the values on the number line that are less than or equal to, based on the closed dot, to 7. So when we move to the next one, we're going to notice n, we're going to read this as n is greater than 15. That's going to be an open dot because of the symbol without the or equal to. So we're going to mark 0. 15 being positive will be somewhere to the right. I'm going to mark an open dot because of the nature of the inequality. And then because I'm greater than 15, I know on a number line values greater than 15 are to the right. That's the end of my graph. Last but not least, m is less than -3/8. Don't get thrown off by the fraction. We have 0. We know -3/8 is somewhere to the left of 0. Whoops, less than, actually change my colors so that I match up accordingly. Less than means that I'm an open dot. without the, because it's not with or equal to, and less than means to the left of my given value. And you're done. Okay, so these graphs basically give us a visual representation that any number on this number line, the infinitely many values on this number line within these boundaries, make these inequality symbols, or these inequality statements, true. So now that we've learned how to build from the solution, and these are all solutions to the graph, we're going to work backwards. We're going to quickly work from graphs backwards, okay? So here's a graph. I can see that I have -1 as my boundary. I can see I'm to the right, which means I'm going to be greater than, but it's a closed dot, so I'm going to be or equal to. And I'm going to have some variable, some unknown, let's call it x, is greater than or equal to -1. The reason why I know it's greater than or equal to, well, it's or equal to because of the closed. It's greater than because it's to the right. And here's another little thing I'll let you in on, a little trick I'll let you in on. If you always start with your variable, then the direction of your inequality symbol will point in the direction that the graph is going. So my graph is moving to the right. My inequality symbol is like an arrowhead that points to the right. If you notice back up above, my inequality symbol in x is less than or equal to 7 was pointing to the left, and my graph was drawn to the left. N is greater than 15. My inequality symbol is pointing to the right. My graph goes to the right. So that kind of takes the guesswork out of this as long as our solution is written in the proper order with the variable for us. So that being said, I know that x is, I'm pointing to the left, is less than, open dot, so not or equal to, simply 12/5. And we're done. You notice my inequality symbol points to the left, which matches to my graph pointing to the left. Last but not least, some variable. I'll use x one more time. It's pointing to the right, which tells me it is greater than, but again, not equal to, it's an open dot, the given boundary, 341. So that's all I want us to get used to today, knowing how to graph from a given solution and knowing how to write a solution from a given graph. And there will be more practice posted for you tomorrow on this where you can demonstrate your understanding further. We'll see you then.